Welcome to solverfy.
So we can say that first for part A, the wave function is now given by psi. And this would be of x of t. This is going to give us psi times e to the I times kx minus omega t. We can then say plus e to the negative I times kx plus omega t. And in this case, we can then say that this is going to be equal to psi times e to the negative I omega t, and this would be multiplied times e to the ikx minus e to the negative ikx. And we can then say that the absolute value squared would be equal to essentially this entire term squared, and this is giving us essentially psi times e to the negative I omega t squared multiplied by e to the ikx plus e to the negative ikx squared, and this is going to give us psi squared times e to the ikx plus e to the negative ikx squared. And we can then say that this is going to be equal to, we can say over here, this will be equal to psi naught squared times cosine kx plus I sine kx, and then this would be plus cosine of kx minus I sine of kx. This would be squared. We can say that then, let's draw a little smaller, psi of x and t squared would be equal to 4 times psi squared multiplied by cosine of kx times, rather, squared, and this is equaling 2 psi squared multiplied by 1 plus cosine of 2kx. And this would be our answer for part A. Now for part B, we're going to consider two plane matter waves, each with the same amplitude equaling psi over radical 2 rather. We can then say that they are traveling along opposite directions along the x-axis. So we can, the combined wave is a standing wave, and then we could say that here psi of x and t is going to be equal to psi of e to the I times kx minus omega t, and this would be plus psi times e minus I, well, e to the minus I kx plus omega t. And again, we can substitute e to the ikx plus e to the negative ikx multiplied by e to the negative I omega t, and this is going to be equal to 2 psi cosine kx times e to the negative I omega t. And so the squared amplitude of the matter wave, then we can then say squared. This is going to be equal to 2 psi cosine kx quantity squared times e to the negative I omega t quantity squared. This is going to, rather the absolute value squared, this is going to be equal to 2 times psi squared times 1 plus cosine of 2kx. This is shown, this graph right here is shown right here. So this would be, this graph right here corresponds to corresponds to part B. Now we're going to set this for part C, we're going to set this to 0, and essentially setting this equation to 0, we can then say that 1 plus cosine 2kx equals 0, and so cosine of 2kx is equaling -1. And this gives that 2kx is going to be equal to 2 times 2 pi over lambda. And this is going to be equal to 2n plus 1 multiplied by pi, where n is equaling 0, 1, 2, or 3, basically any integer. So we can then solve for x. X is then going to be equal to 1/4 times 2h plus 1 times lambda. And this would be our answer for part C. For part D now, oh wait, sorry, this is, my apologies. For part D now, we can then say that the most probable positions for finding the particle where the wave equation is proportional to 1 plus cosine of 2kx. This is where it reaches its maximum. This is where it would be most probable for finding the particle, where this proportionality is at a max. And we can say then cosine of 2kx would be equal to 1, so that this would be at a max. And we can say 2kx is equaling 2 times 2 pi over lambda. And this is equaling 2n pi, where n is equaling 0, 1, 2, 3, again, any integer. And we're going to solve for x again, and x is simply equaling n times lambda over 2. This would be our answer for part D. That is the end of the solution. Thank you.